Good afternoon, ladies and gentlemen, and welcome to Eurocontrol headquarters here in Brussels and this webinar on disciplined flight plan execution. Wherever you are, between Austria and Australia, or Belgium and Brazil, we've over 700 people registered for this webinar, and I'm really grateful indeed that you have decided to dedicate your lunchtime, your breakfast time, or your dinner time to be with us today. And what a great session we have ahead of us with some really interesting panelists to join as well. Today, we're focusing on disciplined flight plan execution, one of the top 5 priorities and areas for optimizing capacity this summer in the Eurocontrol network. To provide a comprehensive view on the topic and better understand the impact of local decisions on the broader air traffic management network, we've lined up a panel of these key experts. Aaron Echinger from EUROCONTROL, Director of Air Control, Matilda Dorfsman, ATM Manager at Ryanair. Then we have Chris Woodland from Airlines for Europe and also Eurocontrol Aircraft Liaison Cell. And last but not least, Anne Pereira from Air Portugal, Technical Training Advisor and Pilot. And I am Stephen Moore, the moderator of this panel, Head of Network Management Operations Division here at Eurocontrol. And as I say, it's a great pleasure to welcome you all here. Today, we're going to be discussing, amongst other things, what do we mean by disciplined flight plan execution? What does it really mean? What could we gain in terms of capacity if we kept all aircraft adhering to their flight planned vertical level? Why is it important to follow the flight plan? What's the difference between the flight plan and a tactical operation of the aircraft? And what is the perspective from the flight deck and from the air traffic control units? So plenty of areas to cover. As you can see on the screen in front of you, should you wish to raise a question, you can see the Q&A button on the Zoom interface, which will allow you to put your questions right in front of me, and I'll be able to filter through them and ask them of the panelists. If you've got any issues, please use the red chat button where my wonderful team of colleagues will be able to help you in the background dealing with whatever issue that you may have. So without further ado, it's my great pleasure to frame for you what we're talking about over the next 55 minutes. Disciplined flight plan execution, we are limiting ourselves to the vertical premise here. We're not talking about shortcutting on the route. We're merely talking for the next hour about the vertical application of this execution of the flight plan. So I'm not sure if my bipper's working or not. So from the 1st of June to the 31st of August last year, we had nearly 600,000 non-adherences of the vertical parts of flight plans for that 92-day period, of which we ended up with 200,000 aircraft being planned but absent from the airspace which had been regulated, equating across those 92 days to about 2,300 lost slots per day. Nearly 4,000 of these vertical non-adherences ended up being unplanned entries into regulated airspace. So an airspace volume that has been regulated because of capacity or some other reason. We had over 4,000 additional flights a day into some of these regulated airspaces in total. Of the total non-adherences, that nearly 600,000, over half occurred when there was no adverse weather about at all. So it's not just weather avoidance. Why does disciplined flight plan execution matter? So I thought the easiest way of doing this was to use a picture. Well, 3 pictures, in fact. So the first picture there, you can see a volume of airspace in the green. Let's call it ANSP1's airspace. And you can see the planned trajectory of a flight from the left to the right-hand side of the picture. And you can see the actual flown trajectory in the red. And what we're saying here is that in this instance, the aircraft was planned through the airspace, the black line, that was regulated, but in actuality, it was climbed above it and remained, for the most part, well outside that regulated piece of airspace. So the aircraft was planned to be in there, but it was absent. Planned but absent. Remember that. On this second picture, in the middle of the screen here, the roles have been reversed, and the planned trajectory remains the black line, and you can see this flight was planned to pass underneath regulated airspace, but the actual trajectory, it was climbed into the period, the portion of airspace that was regulated. So in this case, we refer to it as an unplanned entry. The aircraft was not planned to be in that volume of airspace, but it went in there. Of course, it was all coordinated, it was all safe. However, in the planning phase, the flight plan and the capacity planning of this particular ANSP, ANSP2 in this case, that flight should not have been in that traffic count. When you put them both together, you can see that sometimes we could consider ourselves as having a double loss of capacity, perhaps. By which I mean, it was planned to go through ANSP1's airspace. It ended up going through ANSP2's airspace with the red line. ANSP1 regulated because it had an issue with capacity, but one of the flights, at least, didn't go through the airspace. So it ended up in someone else's airspace, in the blue ANSP2 airspace. And the point I'm trying to make here and get across is that ANSP2 may well, yesterday, have had exactly the same experience and has regulated today at a level lower than it actually could take in anticipation of having additional flights that are unplanned coming into the airspace. That, in effect, means we've got a double capacity loss. We've lost the space where the aircraft should have been, and anticipating an unplanned entry, we've lost a regulation amount in the blue airspace, the ANSP2 airspace. There's no questions at the end of this in terms of checking your understanding, but I hope that's helped a little bit to frame what we're talking about. We have some definitions just so that you understand, if we use these phrases, what we mean. I've done unplanned entry and I've done planned but absent. The next one I just want to cover very briefly is over delivery. This is where in a regulated piece of airspace, more traffic appears for the hour of concern than set by the rate in the regulation. So for example, if there's 40 aircraft per hour by regulation, but 45 aircraft turn up, we've got an over delivery of 5 aircraft in that period, hour, for let's say. Overload. Now, overload is literally a situation where a controller, an air traffic controller, reports themselves as being overloaded. It may or may not be because of too many aircraft. But an overload does not automatically equal too many planes. It is an amount of work above which the controller felt comfortable. Overload. And then finally, overcount. And this is what we've called where an unregulated piece of airspace, so airspace that has a nominal capacity of, say, 50 aircraft an hour, but it's not been regulated, has more traffic than that nominal monitoring amount of 50 per hour. So if there were 55 aircraft in an hour, that could be an overcount for a sector that has a nominal value of 50 aircraft in an hour. Again, it doesn't mean that there's been an overload or an overdelivery, it's just against a certain value. So I hope you kept up and made some notes, because this could help you as we get into the conversations with the panelists. I just wanted to give you some ideas of how this looks every day in the network from the different flight plans that we receive. These are some examples from a month or so ago. These are all showing you a vertical profile of a flight. There's 4 examples. I'll bring them all up because I don't intend to talk through them all. And maybe the one on the top right is a good one to discuss. The aircraft is filed at a certain level, and as you can see, it has a huge descent before climbing back up again and then descending presumably to its destination. There's no way that aircraft has flown that flight profile that was filed. Same for the one directly beneath the bottom right-hand side. No chance that flight was climbed, then descended 4 times as that, then climbed again twice, but that's what it filed. This isn't making the airline wrong that's filed this, it's just data. This is what is filed, and this is what we mean when an aircraft doesn't maintain the flight plan execution or doesn't have disciplined flight plan execution in the vertical phase. If you're going to file that, fly it. Or if you're not going to file that, file what you intend to fly. But there's a lot more to it than that, and we shall come on to that very shortly. Every day we can see examples, in this case where an aircraft is filed every day at flight level 280, and in the red arrow you can see the various levels it flew at, and never at flight level 280. Okay, so again we have issues going into other airspaces, losing capacity, gaining additional loading of traffic. What to do about this for the summer? Someone submitted a question in advance, and thank you for doing so. What would we save if everything flew at the level it filed at? Well, here's the answer. We did some work in the background and simulations on the events and the traffic loadings of last summer, and we came to the conclusion that on non-weather days where convective weather hasn't affected the network, about 13% of delay could be saved in some ACCs. Extrapolating that up across the network, again on non-weather days, we reckoned about 8% of the total delay could be reduced in a busy network day if aircraft flew at the levels they'd filed at. That's quite a lot of capacity gaining, and certainly as we look to a very busy summer with an increase of 5% in traffic coming up this very summer, that could make a significant difference to the punctuality of the aircraft in the network. There's also a safety element, which I'm sure my colleague Aaron will bring up from an ANSP perspective. But just from the Eurocontrol perspective, in 2024, of all the hours of regulations that we had, 75% of those regulated hours had over deliveries of traffic. You can see why it was good that I gave you those definitions. 75% of all hours had more traffic than the regulation stipulated. Of these 75% of hours, 95% had unplanned entries in them. So it wasn't just other stuff, it was exactly what I've described. That's significant and something that really we need to talk about. We've done a lot of work since last summer on the causes of deviations, and I've broadly split them into, with my colleagues, 4 categories, which I'm sure we'll discuss very shortly. Flight planning. About 30% of what we looked at were issues with flight planning. Again, not making anyone wrong, just flight plans that were submitted a bit like the examples I gave earlier. Around 20% of those that were investigated were to do with airspace structure, restrictions in the airspace or routes that you can't fly from various points to various other points, or free route airspace and things of the such like. The penultimate one was to do with aircraft performance, and indeed I'm sure we'll come on to that. Different aircraft types, different weathers, different city pairs, aircraft performance has a significant part to play. And then finally, the last category was what we classed as ATC pilot interaction, or pilot ATC interaction if you want to look at it the other side. We're not saying anyone is right or wrong here, we're just saying the conversation that happens between the flight deck and the controller where a different level is agreed upon for the phase of flight. For whatever reasons. So broadly speaking, four causes and close enough to an equal spread between all of those 4 causes. So I really hope that gives you a significant understanding of what we're about to discuss. Here at Eurocontrol, we've got much data on the subject. I don't intend to go into the next couple of slides, but just to give you an idea, this is an overview of our discipline flight plan execution dashboard. This is available not just internally to us here at Eurocontrol Network Manager, but also to all of our stakeholders in the network, primarily, of course, the airlines and the ANSPs. We can see city pairs, we can see by country, we can see by aircraft type. I think the next one looks at some of the analysis that's available to us. Where was the climb or descent carried out? I.e., was it carried out in the UK and then did the French inherit the problem, or vice versa, or was it carried out somewhere else before the aircraft even entered Eurocontrol's airspace? And then again, the same from aircraft operators' perspective, by type, by route, by city pair, you name it, we're looking at it to try and help alleviate this issue in the network. So you've heard far too much from me. As a moderator now, it's my great pleasure to be quiet and introduce our first speaker, where we think, network, and discuss with the panelists the discipline flight plan execution. So I'm going to invite Aaron from EUROCONTROL to take the floor for a few minutes to describe the aspects of discipline flight plan execution from his and an ANSP's perspective. So good afternoon to you, Aaron. Thank you so much for joining us. I really appreciate you and your time. Over to you.
Thank you, Stephen, and good afternoon to you and good afternoon to all. Thank you for this opportunity to speak about this very important topic. This is top priority for EUROCONTROL as well. And just to briefly summarize what we have done during the last couple of years and why we ended up in such a position. The background is that in 2023, when the traffic demand exceeded our capacities in such an extent that required actions, and then when we let's say when we investigated the situations when there was a over delivery or overloaded sectors that had been reported from the ADCOs, by the ADCOs, actually, most of the cases we came to the point that there was an unexpected or unanticipated traffic load on that sector. So you're right, I'm coming from the safety perspective, I would say. As a normally NSP, I can't really see the absent capacity and such things, but I can see the traffic, which is huge demand, and I can see the overloaded sectors in this case. So after, let's say, lessons learned from 2023 summer, we knew that we have to do something. We really need procedures for the ADCOs. We really need some tangible solutions that we can implement. And so first of all, we really missed a tool, a technical enabler, let's say so, and requested flight level tool, an RFL tool that we have developed after 2023, and then we already used it in 2024, and now we fine-tune this tool. But this was the base for all the actions that we have done after that. So now the tool shows a correct data, the precise data for the air traffic control, very user-friendly. As just one click on the label, it is integrated in the ATM system. I think it is very important that if we develop a tool to monitor the situation, to enhance flight plan adherence, then we have to give a tool for the controllers that is very easy to use and that shows correct and precise data. So this was the first step, to develop a tool. And then now what we will do during this summer is that we'll have the procedures in the handbooks and everywhere, how to deal with the situation. I'm very happy that in the presentation you showed us a wider context, let's say so, because I think that discipline flight plan execution doesn't start with the execution of the flight plan. It starts much earlier than even in the phase of a creation of the flight plan. There's a lot of things that affect them. And then regarding this airspace structure, we also changed our behavior, our procedures, our airspace structure according to this, because normally in Hungary, historically, we have huge geographical airspaces with just a few levels. And this kind of sectorization has a lot of, how to say, uncertainty in the system, because there is very easy to fly 2,000 feet higher and 2,000 feet lower. And then all of our expectations regarding sectorization will be just plans and not the real situation. So now we changed the airspace structure. We splitted the sectors not vertically in the eastern part of Hungary. We splitted the sectors not vertically, but geographically. And in this case, it contains much more levels, and that will be the same traffic volume. So this gives us a bit more safety, let's say so. A lot of things that we have done, but still a lot of things to do. First of all, I think that we really need some kind of a monitoring system that is easy to access, like the one that you showed us in the last slide of the presentation. I'm really happy to have such a tool, because most of the cases, the problem is that when we are speaking about flight plan adherence or vertical flight plan adherence, there are a lot of things that, how to say, must be clarified. For example, if I think that half of the traffic is on wrong flight level or unplanned flight level, it can still be a normal sectorization because of the traffic volumes we use. But for example, if during the night we are operating in one sector, all the flights are different level than flight plan or that are in the flight plan, but it's there's no problem of overload, there's no problem of overcount and over deliveries, because it will be still at the same sector. But as during the day we open the sectors, it might, how to say it can be seen that the situation becomes worse and worse. But the situation is the same. It's just the frame, the sectorization where we implement these flight plans or where we put these flights in are different. And that's the point when we start to speak about over deliveries and overcounts, I would say. Yeah, I think this is in a nutshell. I think this is for me for the time.
Thank you, Aaron, indeed. Really, really interesting. So you've introduced a couple of new tools by my understanding and following you, and the airspace structure has changed, which will help manage the capacity more efficiently or effectively. However, at the end there, you gave a very good explanation, far better than mine, about how it affects difference between nighttime and daytime. And although the aircraft could all be in the same place, actually with the different sectorization of daytime, that could cause some of the problems. So we're going to just change the angle of attack to the problem, if you like, and it gives me great pleasure, as always, to introduce my colleague and friend Mathilde Dorfsman from Ryanair as the ATM manager there. Good afternoon to you, Mathilde. It's lovely to see you. You're actually round the corner from me, I think, but I haven't yet seen you face to face. So welcome to Brussels and to HQ. I'll look forward to catching up with you afterwards. The floor is yours. Thank you.
Thanks, Stephen. I hope everyone can hear me well. Listen, I think it's really for us critical to examine kind of like the broader context that you've also mentioned and the multiple factors that are leading to all those disruptions when we talk about flight plan execution. As you mentioned it on the slide, it's not like one person's fault. It's really a conjecture of multiple factors, and we need to take into account those constraints that are causing the deviation. Just like it was mentioned, it may be about safety, about a conflict with another aircraft. It may be due to weather phenomena like turbulence or thunderstorms, but it might also be due to the traffic and the sector optimization, just like Aaron mentioned, and the limitation of the airspace. For the airlines, the planning stage for the filing of the flight plan is probably around 12 hours before the actual flight, at least in intra-Europe. That means that the route that we will file is a theoretical plan that might not take into account kind of like the latest informations of the network. In Europe, it's mostly automated through the CFSPs, meaning it's mainly the machine actually working on the logic and building the flight plan. For us airlines, the goal is always and will always be to have the most efficient routing, taking into account a lot of different criteria. But sometimes what we face and what you actually really know is a highly fragmented airspace with a lot of restrictions on the sectors and a lot of RATs that keeps on adding on and adding on every single year, meaning the system doesn't allow us to plan for the specific routes due to those restrictions. And it's therefore not the most efficient route that we can plan. There's a lot of things that we can see, that forbid us from filing those routes, but actually every single day we get given those routes, even though the system doesn't allow us to actually file them. In any case, when we file the flight plan, we always take into account the aircraft performance, and we will always file to the levels that are reachable at a planning stage. And then we always fuel for the flight planned routes. That is something that is, I think, important to say. I think nowadays, the question is, with all the technology available, why do we still not have a system that allows the ATCO to see the impact that giving a different flight level will have on another sector, on another airspace afterwards? It's also bring us the question of why the most efficient routing is not available to use for flight planning purposes, and how all the airspace is structured and actually regulated. Airlines are literally doing their best because to find the most efficient route with all the information that we have, and it is definitely not our goal to deviate from what we have. I think there's a lot of things that we can do as a whole network to enhance and optimize those routings through a lot of communication.
Thank you, Mathilde. Loads of great points there. In fact, I've had to cross off some of the questions because you've answered them already, particularly that one about we take enough fuel for the flight plan rather than what we might expect to happen. So thank you. I won't ask any questions on that, but that's been a really great introduction from an AO perspective. I'm going to now turn to another friend and colleague who's in the building, Chris Woodland, Airlines for Europe and an airline liaison cell officer as well. Chris, thank you. Good afternoon to you, and the floor is yours.
Good afternoon, Stephen. Hope you can all hear me.
Perfectly, thank you.
Okay, good. I think it's clear we need to point out this is not something new. This has been going on for a number of years and has just been exacerbated by the huge traffic increase we saw last year and the restriction on geographical areas. There are so many factors involved here, and I know we go around and talking about this, but we need a clearer identification of where these occurrences are happening in the network, and especially at what stages of flight. From a flight plan calculating perspective, as Mathilde said, you know, everything is done according to all the rules we are given. We're flight planning for it. And I just wanted to highlight a few things that I noticed in the work I've been looking at. The huge increase in RAD measures is playing a big factor. It's getting really complicated now to get a good route that's complies with all of these things. And we have to look at things like some of these RADs that are creating yo-yos. On a few occasions, and there is many occasions that I've pointed out that RADs are actually causing yo-yo profiles which are never flown, especially when they're built over points and not over airspace. And one thing we really need to look at. The other thing as well we need to take into consideration is the profile tuning restrictions, the letter of agreements, which airlines don't plan for because we're not aware of them. You know, an agreement from one country to the other is not visible to a flight planning system and is not used. So these are having a big impact on non-adherences as well. Something else that I think needs to be looked at is the quadrangle rule. You know, when you're flying east, west, west, east across Italy, somewhere like that, you're having to descend, which is never performed. You're going from odds to evens to odds. It's never happening. The data I look at never happens. The crew just stay level, as do ATC, makes it less complicated. The city pair level cappings, some of the data that I've looked at from the NM dashboard, over 300 occurrences on city pairs alone, 300 city pairs, never made, always above profile, always above the RAD measure. So we're applying the RAD in our flight planning systems, and then we're always getting higher and higher. Okay, well, some of this is at night time when it's not so busy, I get it, but these are all still part of the non-adherence. Another thing I'm starting to wonder about is free route. We need to have a real in-depth discussion on free route because it is built in different ways in different CFSPs. So the longer the DCT, the less profile you can get out of a flight planning system. So the more directs you're having, when we had the airways before, we had a lot more points to do the profile change. Now, if you have a direct of 700 nautical miles, you've only got the first point and the last point to make that change. So I'm sure crew are optimizing in between that to get better levels. So maybe the direct airspaces maybe need a little bit of work. The whole RAD process needs a major overhaul to make it less complicated and remove legacy rules. I've identified a number of rules that were no longer needed. They were there for old aircraft types. So I think a real good in-depth look at the RAD, and we've asked for this for many years to be done, has to be taken place. You know, all this stuff is making it very, very complicated for airlines to build routes. You know, even a route building from one airspace to another over an AIRAC cycle is really, really complicated. And it's taken airlines 2 or 3 weeks to, you know, get up to speed on AIRAC cycles. And we're trying to address this in the AOLC position by sending the airlines all these new routes that, you know, these airspace changes. But maybe a bit more joined up approach in free route would really help. Something else we need to look at as well is when we have to profile under military areas that are no longer active. I quite often see in the data that we've planned under a military area, yet we're getting the optimum profile through it. So yeah, another thing we need to look at. So I mean, airlines, you know, we all have things to do to help. You know, I quite often see where some of the profile changes that Stephen showed at the beginning, flights are descending for very little cost saving. You know, some of the airlines I've spoke to, it saves $50 to do a number of profile changes over a short distance. You know, smoothing out these profiles would help. And we need to realize that, you know, $50 is not as accurate as, you know, as possible. So maybe there is some identification to be done by airlines on that. On the back of that, you know, as Stephen pointed out, we've built this dashboard. It's really, really useful. It really highlights when there is a problem with a particular, for whatever reason. But we also have to look at the data a bit more in depth. You know, a couple of things that I saw come out of it, which really stood out, was the amount of cargo carriers that were not adhering. And, you know, we have to understand the nature of the cargo business, that, you know, if a truck doesn't turn up, that's a huge amount of weight on the aircraft that's changed. And okay, we should be updating the flight plan, but, you know, we've been discussions on this. You know, airlines want to give NM the correct data, the profile, the route and everything else. But, you know, changing that at the last minute in the middle of summer can lead to some very big penalising regulations. And this late updater thing, I know we've gone over it. We can keep discussing it. Needs to be discussed. And of course, the cargo carriers are flying mainly at night. So is that really an impact? The other thing I've noticed and really stands out is the GABA traffic. They're really penalised in some of the airfields they go to over the RAD measures. They have very high performing aircraft that cannot get away from these aircrafts, and they're forced to be very low. But yet air traffic is giving them a really good direct route into the upper airspace. And we need to really look at this. It really is one of the top ones. The GABA comes out second or third in these non-adherences. And I think, you know, to round it all up a bit, I think overall, I think the network needs to bring more stability. The more stability we bring to the network in summer by all working together in a CDM process will improve the non-adherence. So we're not all fighting to get under restriction, round restriction. We're all working together in a timely manner for the network. And I think, you know, I encourage people to use this dashboard that's been produced. We're working on it daily to look at the city pairs. And a lot of airlines, you know, are actually making fuel savings using it because it's the way routes have been built. They've not been adapted for the free route airspace. You know, we've highlighted that there's certain aircraft performance on some types of aircraft that doesn't seem quite right. And airlines have gone away and working with that, and they're very responsive to this data. And, you know, looking at it from a fuel saving perspective is a really good angle with this. So that's about it from me at the moment, Stephen. Thank you.
Thanks, Chris. Wow, a load of points there. You've mentioned a few acronyms, RAD, late updaters, GABA. RAD, we just mean airspace restrictions, for want of a better phrase, normally structurally in place to help air traffic control know which way or which levels aircraft are going to be at, depending on where they've left from or which direction they're coming into the airspace from. Late updater is an interesting point. I won't go into too much detail, but in essence, if you change your flight plan, which affects the slot that you've been given, you'll be marked as a late updater and get a slot that moves and then is improved as best as it can be. There are certain parameters, but that's what we mean by late updater. It's commonly seen as a punishment for updating the flight plan late. Actually, it refers to some systematic improvements that will happen. If it wasn't marked as a late updater, it wouldn't happen. But it does feel very much for the aircraft that it's going to get stuck with a much worse CTOT. That's a slot restriction. So thank you, Chris. Lots and lots and lots of stuff in there. Just out of interest, I see lots of people interacting and putting thumbs up and heart signs. I guess that's some cool interaction you found on the Zoom system. However, none of you are typing messages in terms of the question and answers. So please do put your efforts into giving us some questions, and we'll give the efforts to giving you some answers. There's one so far, and that happened within the first 5 minutes. There's over 300 of you connected at the last count. So please do, if you're putting your questions in the chat, I can't see it even with my glasses. They need to go in the Q&A, please. So please put them in the Q&A. Now, it gives me my great pleasure indeed to introduce our final panelist. Anne from Portugal has landed back this morning from somewhere, I forget where, a long way away. So thank you for 15 cups of coffee you've had since I saw you 20 minutes ago, and for still being with us. Good morning to you, Anne. Good afternoon to you, rather. And thank you so much for joining us. The floor is yours.
Good morning, Stephen. Thank you for having me here. I flew from São Paulo, so that's a long flight, and landed this morning. So I'm happy to be here sharing with you the flight deck perspective. We are often forgotten in this debate. At the end of the day of this huge work done backstage, we are the end executioners. And while there's a big effort in the flight plans, I want to explain why sometimes we as pilots don't strictly adhere to it. And there's a big reason for that. The aviation environment is incredibly dynamic. The conditions can change significantly between the time of the flight planning and the actual flight. And actually, as pilots, we fly. Our flight management is based on fuel conservation policy. So this fuel conservation policy is based on in-flight speed, vertical and lateral navigation management. For speed, we have to fly at the most economical speed during climb, cruise, and descent. This speed is provided in the flight plan. For my experience and my company, we should maintain this economical speed even though the flight is delayed. So any increase of speed would have to be requested by our operational control. We are not encouraged to change it by only if there is, of course, a safety issue related. If the flight is ahead of schedule, it also does a limited sense to reduce speed because maintenance costs are associated with the flight time. Now I'll talk about the vertical navigation management. So as you know, we have to fly at the optimum flight level. As fuel is consumed, the aircraft weight decreases and it changes the optimum flight level for fuel efficiency to a higher flight level. The optimum cruise flight level is calculated according to the airplane weight, the outside air temperature, the winds, and the cost index associated with the flight. As a rule, we should fly at the cruising level calculated by the operational flight plan, because the selection of these levels is optimized and we often don't know what is incorporated. The onboard system might lack some information that is inserted at the time of the calculation of the operational flight plan process. However, when the conditions differ from the ones that were calculated during the flight plan process, then the onboard system, the FMS, is a valuable tool for us. So what we note is that the flight levels in the operational flight plan might result from airspace operational constraints that are other than environmental, for instance, ATC constraints. And although they are present in the flight plan, we would fly at other more efficient flight levels if they are offered or accepted by the ATC controllers. So that's really important, and that's maybe one part of the problem. Also, as I've said previously, the atmospheric conditions really differ. They change. They are really dynamic every day. Winds and temperatures change. They are crucial for determining the optimum flight level, and they really can deviate significantly during the flight. We are requested to upload the latest winds and temperature available. That happens every 6 hours. So by the moment we upload new winds and temperatures, the onboard system, flight management system, will take precedence over the flight plan in telling us what the optimum flight levels are. Also, and we are encouraged to do it every 6 hours and before the top of descent. Another very important variation is that the aircraft zero fuel weight at the time of the flight plan filing and the actual one differ. And that will change completely the aircraft's performance, and we might not be able to achieve the filed flight level. So this is really important. And this is about my limited knowledge of late updates. I believe that we have a policy about filing a new flight plan. So it would be if the weight, it's 2 tons about the zero fuel weight that was estimated. So if it's not, if it's below 2 tons for my aircraft, we won't file a new flight plan. So that means that, but in terms of achievable performance, even a ton changes a lot on the maximum flight levels that are achievable by the aircraft. Also, at the time of the pre-flight, we review the flight plan, and if the commander sees or oversees that he expects significant deviation from the flight plan, we put extra fuel on the aircraft, and that will also have an impact on the zero fuel weight and the flight levels. At last, for the vertical, the optimum top of descent is the one that is provided by the FMS on board. So it might differ also from the top of descent from the filed flight plan. At last, the in-flight lateral navigation management, we are encouraged to ask and request direct routes to the ATC whenever possible. So this is our policy, and that's what we are encouraged to do as pilots. Also, something that is very important, and I have already mentioned to Stephen, is that there is a lot of tactical considerations in this debate. As we fly tactical during the flight, we fly strategically, because we are not flying according to each airspace we are entering. We are overlooking for the whole flight for safety, efficient conduct of the flight, but above all, safety. And that includes discretion for us to deviate from the flight, from the filed flight plan whenever it's necessary, and to adapt to the changing conditions. So I think that personally, one part of the debate is that as long as the operator's flight management is based on fuel conservation policy, it will take precedence over the strict adherence to the flight plan. So I guess there's a lot of work that should be done. You know, we might go in the middle, you know. So, and at last, I want to say that pilots might not have a deep awareness of the issue of flight plan adherence. Okay, so that's it. Thank you.
Wow, thank you, Anne. Some great stuff there as well. And I'm really interested in the last statement, really, which I'm not going to quote as yours or an Air Portugal one, but you know, fuel conservation versus flight plan adherence. It's X versus flight plan adherence, or Y versus flight plan adherence. Do we take the most efficient routing? Efficient for fuel, efficient for airspace, efficient for the environment. It's a really interesting point, isn't it? Because my counter thought immediately as I was listening to you there, and as I see the panelists coming back up on screen, was, well, who cares then? Let's just carry on as we are. Okay, it's 10% of the airspace capacity potentially lost, or 10% of delay that we could regain. But you know what? If we can all do what we want and deal with those very operational last-minute changes, what does it matter? Chris, what does it matter? He's trying to find his unmute button now, I hope. So the question generally is, look, if we want to keep a bit of flexibility, if we have pallets of cargo that don't turn up, or we have a bit of extra fuel because of potential weather en route, but we can't update the flight plan, it's so late, what does it matter? Come on, it's only 8%, 10%.
But it does matter to the capacity and the peak of the day. You know, if we can update the flight plan with trajectory and everything, then you know, we're giving the correct information to everybody, you know, and this is the way forward, isn't it? This is the future. But doing it today, you know, as TAP said, you know, they have policies in place. A lot of airlines have policy in place about last minute changes. And, you know, I hear it from a number of airlines that I've worked with recently that, you know, they're not updating the flight plan because of profile, because they're getting worse delay.
Yeah, there's some really good points there, and I'm sorry to interrupt you. I just see loads of questions flying in now, so thank you for those that said they'd show me what then, and give a load of questions in the question and answer area, because there's about 50 just rocked up, which is really good. So why file flight plans then? If we're going to just get the very most optimum out of the situation as we find ourselves on the flight deck or as controllers, why bother with a flight plan, or why bother with updating any flight plan, even if it's done 3 hours before? Mathilde, from your perspective, from an airline perspective, what would you rather have? A bit more capacity or a bit less delay, or the ability to do what you want in the last hours before and during the flight?
Everything at the same time? Can I have it?
It's an extra charge for everything at the same time.
I mean, you have to play with everything. For us, the cost of delay is huge. So reducing the delay would be more beneficial for us. I think it was estimated that 1 minute of delay is €127 for the airlines. So you can imagine that multiplied throughout the summer, like how much additional cost it is for us. And I think in order to reduce delays, you have to add more capacity in the air. Like they go together. So that's why I say, like, I need everything. And I think what Chris just mentioned, and it's something also we've talked about a lot, is like, if you want us to give you the most updated flight plans, we will do it. Just why would we get penalized to give you the most updated information of what we're actually going to fly? And this is a bit of the question and the issue with the late updater, is that it's a penalization for us, but at the same time, it would be very beneficial for the ATC to know what we're actually going to fly.
Yeah, thank you. Oh, I'm just going to open microphone somewhere along the way. That's a really good point as well. We're not going to dive into late updaters, but I do feel that we need a whole new webinar on late updaters, but maybe we'll offer that after the summer. But I do take the point internally, as it were. But you did raise an interesting point. €127, let's just take that as a given. €127 for a minute's delay. So if you flew what you last filed, notwithstanding the restrictions that you have and subject safety, you'd get a bit more capacity and have less delay. Surely saving $50, to give Chris's example, on some of these flight plans versus 127 minutes of delay. I mean, you've only got to save half a minute of delay to make more than you're making by a dodgy flight plan that's never going to get flown. Why are we bothering? Why aren't we just concentrating on filing the very best flight plans, noting all the restrictions that we have, and gaining less delay? That's got to be the way forward, hasn't it? Would that help you, Aaron, if all the pilots, sorry, not pilots, if all the flights flew at the level they filed?
I would see it. I mean, I think many factors had been mentioned here, all the contributing factors, and many of them are systematic issues, I would say. And I completely agree with Chris on his points. One point is missing for me is the human factor. I mean, the behavior of the ETCOs and pilots. And then when we have these procedures, I think that this is how we have to tackle this issue on a short term. I mean, for this summer, if we would like to just go to that direction, that, for example, an ETCO would check the requested level of the flight, and when the pilot is asking for a level, he or she would check whether is the what is the flightman level for that section of the route. I just, because I think there must be a normal ratio of inadherence. I mean, this is a, as you mentioned, this is a dynamical environment, and yeah, but there must be, for planning, for design perspectives, there must be, let's say, it's okay that 20% of the flights are inadherent. No problem. In this case, I will plan my sectorization, design my race spaces according to this. It's okay. But now what I can see is the situation is worse and worse, and then don't know where to go. I mean, so this is why I think human factor would be very important, and that would be the question to your I mean, that would be the answer to your question, that just for one day, let's see if everyone would stick to the flight plan as much as he or she can.
Let's propose an international fly the damn level you filed today, just to see if that makes a difference. That seems like a good idea. Just a question then for you, Aaron, one more before I come on to Anne. Aaron, the RADs that you have through your airspace, do you review them? Do you review the necessity and the need? There's lots of questions around that for the whole network, but from your perspective?
I think that in Hungary, I mean, the geographical position of Hungary is in the middle. I mean, we don't have many routes, so I think this is more for the western part of Europe, let's say. So of course we overlook them regularly, but I don't think that in our case this is the main reason of inadherent flight plans. The main case in our the main cause in our case, I would say, is that we are somewhere between the eastern and western part of Europe, and the mindset is very different, and I think the whole systems are very different between.
Okay, thank you. And you make a good point there. One ANSP is different to other ANSPs, so for sure there are many more ANSPs over and above that in Hungary, which have lots of RADs. So a well-made point. So we've got on the table there then for this summer, and human factors is the way forwards. Understanding what flying at a different level, subject safety, really means in the network. From a pilot's perspective, how much of this is well known in the flight deck, or is it just the computer says 380 is the level for today, then just ask for 380?
As I said before, we are encouraged to adhere to the flight plan because it has been optimized and calculated with optimization until the conditions vary from the flight plan. For instance, if I'm given a lower flight level, in a given sector, I will burn more fuel. I have to get this fuel back. As I said, if you look at the debate in a tactical way, then it cannot work for us because we cannot get this fuel back, the fuel that we have burned in a sector we were not supposed to. Of course, we have contingency, but we have to manage the contingency because at the end of the day, as I said before, this is a strategic mission where we have to ensure the arrival at the destination with sufficient reserves, either to proceed to an alternate or to be committed to land, and to land with the fuel remaining above the final reserve fuel. And this is not a matter of organization or operators. This is our license. Okay, so again, look at the issue in a strategic perspective. This is not human factor. This is, I guess, that each stakeholder has a different constraint and objective, and we need to kind of align the objectives to make that work.
No, that's a really good point. Thank you. I was just having a quick look through some of the questions, and as you were saying it, I came across almost a statement rather than a question from Glenn Bradley. Sorry to name you by name, but many thanks to the presenters. It's apparent the needs of ATC, who are always looking to optimize capacity, do not always align with that of the airlines, who are always looking for optimum solution, which I think is a perfect summary of what you were saying as well, notwithstanding the licensing part as all. So for this summer, then, it feels like, other than awareness, we have to accept the situation for what we have, the work that the NM and that Chris and some colleagues have been doing in the background to try and reduce the noise, but also contact airlines and ANSPs to deal with relatively the non-adherence repetitively on city pairings and the RAD issues is in hand. But more strategically then, just on Anne's last word there, what can we do for the future? There's loads of questions about flight optimization apps in the cockpit, you know, having the flexibility to, in essence, pick up on what Anne was saying, do what's required for the weather situation that you find it. Is that the future? Mathilde, do you think that's something that the airlines are going to be looking to do more of to get the very best and optimal? And if so, I'll have to come to Aaron to find out how he's going to be able to accommodate it.
Well, no, yeah, definitely. This is what we want. You know, with the most optimum and efficient flight plan, the less fuel we consume, the less pollution there is in the air in the end, and the better on-time performance will we have. So definitely, I think we just need to do not underestimate that the European air traffic challenges is like a structural capacity deficit, and we are in a very fragile structure that struggles to meet the demand, even sometimes when there's not a lot of traffic.
Thank you. And Aaron, if all the flight decks had optimization software on them, and I know the machine tells, the FMS tells the pilots what the best level is for any given stage of flight, but optimizing the flight away from the flight plan en route, will you be able to cope?
Yeah, I think with the TBO, this is what we expect from TBO, and I think that all ANSPs have to think what to do with the data that they will get, because now I think that we have a situation we are facing with lack of data or insufficient data or something, but by the time we will have precise forecast of the traffic and our expectations can be very, very precise, is our airspace dynamic enough, or our rostering system, a lot of system that can have a good answer to it? We are working on it. I think many ANSPs are working because, of course, we are providers and airlines are our customers. So that this is what I think that we have to adapt to the new situation. We are in this phase, I would say now, but that will be a different.
Okay. Thank you. That's really helpful. So what I'm going to do now, mindful of the time, and thank you all for joining us over lunch, nearly 400 people, I think, if not a few more now connected online, and many more to watch the replay, possibly even some of the panelists. It's my opportunity now to offer to the floor of the panelists their final thoughts on the subject of disciplined flight plan execution. Let's limit it to this summer. Let's not talk about the future. I think the future is something that we're going to look to have a workshop here at Eurocontrol after the summer itself to see what can be different for the years to come. But maybe 30 seconds each as a summary from your position before I close us out. So I'll go in the order that we started with. So that'll go to Aaron just for a quick 30-second summary.
Yeah, just preparing for the summer, I ask all of the stakeholders, because each and every stakeholder has its own responsibility and contribution to this situation now, that just work all together like Eurocontrol asks us. That's all. Thank you.
Thank you, sir. Matilda, from your perspective.
I think, you know, the filed flight plan is a fundamental planning tool, but it should not all be the singular focus of our discussions regarding airspace capacity. And we should really ask ourselves, why are we forced to file those inefficient routings, and how can we improve the network with more accurate information from every single site of the network?
Beautifully succinct. Thank you very much. It's really clear. Chris.
Yeah, for me, I think, you know, looking at the old legacy rules that were still in the system that we had to flight plan to, and I think, you know, one of the biggest things to me is we need to be in more of a network mode, a flow mode than a firefighting mode. You know, getting we're all working together, you know, 24 hours a day to spread traffic rather than everybody starbursting when a regulation comes on. We're underflying regulation, and then an ANSP is letting us go through the regulation, which cause problems down and down and down the route. I think, you know, a better CDM process would minimize a lot of these non-adherences.
Thank you, Chris. And then finally, Anne, the floor is yours.
Okay, I think that we should continue to work together, have more the inside perspective from the end executioners as pilots and ATC controllers. And also, I think that data link and TBO are really the future to help us, you know, to get more airspace capacity.
Thank you, and thank you, Mathilde. Thank you, Aaron, and thank you, Chris. It's been my absolute pleasure to moderate this panel. Thank you to the panelists for all their hard work, not just for the last hour, but of course their preparation in advance. Thank you to everyone who's submitted questions. Sorry we didn't get around to all of them. Thank you to all of those who've been indicating support to the comments that were made along the way. Thank you for joining us. I wish you the very best of Mondays, or what's left of it, and wish you a very safe and happy summer. Thank you and good afternoon.